In this video, you will learn how to troubleshoot the RNA quantification process using a Nanodrop 2000 spectrophotometer. Many of the graphs and information used in this video were taken from biomedical genomics at biomedicalgenomics.org. For further information, please see this site. RNA purity is extremely important for the accuracy of downstream processes such as PCR. As mentioned in the previous video, good quality RNA will have an optical density 260-280 ratio of 1.8 to 2 and an OD 260-230 of 1.8 or greater. This is because nucleic acid is detected at 260 nanometers, whereas protein, salt, and solvents are detected at 230 and 280 nanometers. A high OD 260-280 and OD 260-230 ratio therefore indicates that you have extracted RNA devoid of any of these contaminants. A good graph will look like this. The 260-280 ratio is the most important, but when harvesting the RNA in water, it can be as low as 1.85 and still be pure. If you have low concentrations of RNA harvested in water, lower ratios are common. To avoid this problem, harvest in an alkaline buffer with a pH of 7.5 to 8.5, such as buffer TE with a pH of 8, for a more accurate reading. A minor contaminant problem is ethanol. This will have a large effect in water, but a low effect in buffer TE. One way to remove this contaminant is to allow the spin column to dry before isolating with water. Some major contaminant problems include protein, guanidine isothiocyanate, and phenol. Protein absorbs at 280 nanometers, which will lower the 260-280 ratio. Guanidine isothiocyanate absorbs at 230 nanometers and will lower the 260-230 ratio. Phenol contamination causes the concentration levels to spike because it absorbs at the 270 nanometers, which is very close to 260 nanometers, the RNA absorption wavelength. When dealing with low concentrations of RNA, this can have a greater effect. Depending on which isolation method is used, other contaminants can also affect RNA purity. This graph shows the effects of some of these contaminants. If you suspect problems with the nanodrop itself, first try cleaning the pedestal. Put a large droplet, 5 microliters, on the stand and gently lower the arm. Leave the droplet for 5 minutes. Repeat this procedure once or twice. If you are still having trouble with the nanodrop, perform the calibration described in the first video, instrument and calibration. However, only do this if no other methods have worked. Quality RNA is essential for quality PCR results. Follow these guidelines at all times. To learn the next step in this process, reverse transcription, please watch the next video.